Waste collected from customers in various parts of the country is brought back into the station as raw material, and the amounts are measured using a truck scale. Client names, received items, and their volumes are recorded, and the waste is then classified into either Category A or Category B according to the differences in type and particle size. Category A waste consists of items similar in size whose particle size is small, and Category B waste consists of items different in size whose particle size is large. Raw materials whose particle sizes are not uniform are sorted using trommel sieves. These are the processes that are utilized in the Fuji-style heavy metal solidification cement kneading and manufacturing facility, which is installed at the disposal station. Measured amounts of heavy metal fixing agents and Portland Blast furnace slag cement are placed into the kneading pool and mixed with the waste brought in to produce two types of earth to be laid on the ground, earth type A and B. This earth is covered by product liability insurance, and if an accident is caused by the product, any damages amounting up to 7 billion yen per accident are covered. The Fuji-style earth is loaded into the facility's designated dump trucks and brought to areas where it is laid on the ground. The target areas are measured accurately, and temporary dikes, which weigh 17 to 34 tons each, are carefully transferred using 90-ton crawler cranes to create consolidation yards. Furthermore, partitioning dikes are used to divide the areas into two parts, the area for type A earth and that for type B earth. Fuji-style type B is put into its area and consolidated using a 6-ton bucket. One layer of earth is around 20 centimeters thick, and every corner of each layer is firmly consolidated. In order to ensure that the type B earth sticks to the type A earth, which covers the upper part of the land, the height of the layer of type B earth is confirmed using an automatic level, and a 25 millimeter thick layer of virgin smashed rock is then laid and pounded so that it is kneaded into the type B earth to match the latter's finished height. Next, the Fuji-style type A is consolidated on top of the B area. A stronger and denser cover is conformed by consolidating the type A earth, whose particle size is uniform and fine-grained. After the internal partitions are removed, the type A earth is similarly consolidated into the outer areas, and this marks the completion of the consolidation of the entire area. A 25 millimeter thick layer of virgin smashed rock is laid and pounded so that it is kneaded into the upper part of the earth. On top of this layer, a 40 millimeter thick layer of highly workable mortar is laid and leveled so that the two layers come into contact with each other more smoothly. Another 25 millimeter thick layer of virgin smashed rock is then laid, and a solid cover of liquid concrete is poured on the surface for capping. Furthermore, a 20 millimeter thick layer of smashed rock with a diameter of 5 to 13 millimeters is laid and leveled to cover the earth. The role of capping is to preclude the laid earth from drying rapidly, which adversely affects the hardening of the laid earth, and at the same time prevent rainwater from coming into direct contact with the earth in order to protect the quality of water in the earth. The covering materials prevent the surface of the earth from being worn away due to vehicle traffic. When the laid earth hardens, iron plates are placed on top, and 4 15-ton weights are placed on each plate in order to maintain the prescribed strength and specific gravity of the earth. The expansion of the earth is in this way controlled. When the period of curing has passed and the temporary dikes are removed, the finish on the sides resembles that of concrete structures. The sides are capped by spraying non-combustible, waterproof paint to prevent them from being touched by rainwater. The entire final disposal station is restored as a single tract of solid ground by continuing these areas horizontally and repeating them in the upper and lower layers of earth. The Fuji-style laid earth consolidation method, which consists of the series of processes described above, has attracted much public attention, and Fuji Corporation patented technology is highly rated in a number of fields. Currently, This method emits 4.47 kilograms of carbon dioxide per ton of waste, which is the smallest among recycling methods in Japan, and in this way greatly contributes to protecting the environment. In February 2012, we installed equipment capable of generating 3 times the maximum amount of electricity consumed by the water treatment facilities and the administration building, therefore establishing a fully self-producing, self-consuming system that encompasses all the facilities. Consolidation of laid earth in designated areas ensures the traceability of waste received as raw materials and products produced by recycling it in a process that has up till now been impossible. The Fuji-style system for identifying and managing the location of raw materials allows for immediate identification of the types of waste received as raw materials, the names of dischargers, the laid earth production methods used, the date of production and use, the area of laid earth used, quantities, and the location of use, as well as issuance of reliable, clear, and accurate certificates of recycling to customers.